Hello, I'm Jinyoung Park, who will be presenting Improving Large Molecular Language Models via Relational via Multimodal Collaboration. Now let me begin my presentation. We know that large language models, including multimodal large language models, have revolutionized AI. So, including ChatGPT, Gemini, Llama, there have been a lot of large language models, and they have shown their impressive success in diverse tasks and domains. Inspired by the success of large language model, large molecular language models have been actively explored in recent years. Large molecular language models can perform the multiple molecule-related tasks with only a single model. But large molecule language models have two limitations. First is that prior models typically process molecular data, 1D strings, 2D graphs, 3D conformations in isolation or views them shallowly, which prevents them from leveraging the complementary properties of different modalities. And second, existing evaluation frameworks on molecular language models are generally based on generic text metrics like BLEU and Rauch, which are molecule agnostic, which fails to assess chemical correctness. To address these issues, we first proposed the CoLLaMo, which integrates 1D sequences, 2D graphs, and 3D conformations into a shared token space using relational attention to capture structural and spatial details of molecules. And second, we propose molecule-specialized evaluation metrics. The first one is CHAM. CHAM and RCHAM quantifies the proportion of mentioned molecular entities that are factually incorrect or not grounded in the input molecule. So we validate the effectiveness of the large molecular language models based on their molecule-specialized captions. And second is GPT-based evaluation, which verifies the generated output based on two criteria. The first one is factual informativeness, and second one is alignment with the ground truth. Now experiment. From our main experimental result, we can see that CoLLaMo achieves the best performance compared to other baseline models, including GPT-based models such as GPT-4, GPT-4o, and OR Mini. We also see that our CoLLaMo shows better performance than molecule-specialized language models such as LLMO and more instructions. And furthermore, our CoLLaMo shows its effectiveness on multiple property tree benchmark datasets with its capability to capture both 1D, 2D, 3D molecular modalities. And now is the qualitative results. In the first table, we can see that our CoLLaMo achieves the highest score on our proposed evaluation matrix, that's the molecule specialized evaluation matrix. It demonstrates the superior molecular understanding, capabilities, and generation quality of our CoLLaMo on both automatic and LLM-based evaluations. Second table demonstrates that integrating 1D, 2D, and 3D modalities through our modality-collaborative projector consistently improves the performance across all tasks except motif counting. And finally, third, the evaluation study shows that all components contribute to the performance improvement of our CoLLaMo. And finally, this table reveals that even when only a single modality is available during inference, or some part of modalities are available during inference, our CoLLaMo maintains strong performance, demonstrating its robustness, while the model without co-projector is significantly degraded. And on qualitative results, we can see that our CoLLaMo accurately identifies the molecule as 3-hydroxy fatty acid CoA by integrating complementary cues from 1D, 2D, and 3D modalities, whereas single modality models produce incorrect descriptions such as 3D hydroxy octadecanol CoA. In conclusion, we propose a modality-collaborative projector equipped with relational modality-collaborative attention, which facilitates relation-guided information exchange by integrating 2D structure and 3D spatial relations between atoms. And we introduce CoLLaMo based on our modality-collaborative projector, which integrates molecular multimodal representations into unified molecular tokens to fully leverage diverse aspects of molecular information. And we present a molecule-centric evaluation framework for LMLMs, including an automatic hallucination assessment metric and a GPT-based caption quality evaluator, addressing the limitations of conventional token-based metrics. Thank you for listening my presentation. Thank you.